Echoes of Eternity. Humanity's epic journey to the edge of the universe and beyond. Ever find yourself gazing up at the night sky, feeling both tiny and incredibly curious all at once? There's something magical about those twinkling stars and the vast, dark canvas above us. Today, we're embarking on an epic journey together, a journey that spans from the earliest humans who looked up in wonder, to the trailblazing scientists pushing the boundaries of what we know about the universe. We're talking about traveling to the edge of the universe and even pondering what's beyond. Let's rewind the clock, way back to ancient times. Imagine being one of the Babylonians, Egyptians, or Mayans. These folks didn't just see random dots up there. They saw stories, gods, animals. They connected the stars into constellations that had deep meanings in their cultures. The Babylonians were some of the first to record the movements of planets and eclipses. The Egyptians aligned their pyramids and temples with celestial events. The Mayans had incredibly accurate calendars based on their astronomical observations. Back then, people like Aristotle and Ptolemy thought Earth was the center of everything. The geocentric model was the big idea for centuries. Celestial events were woven into mythology, religion, and navigation. The stars guided sailors across oceans and helped farmers know when to plant or harvest crops. The sky was like a giant clock and map rolled into one. Fast forward to the 16th century, and things start to get interesting. Along comes Nicolaus Copernicus, a Polish astronomer who proposed the heliocentric model, suggesting that the sun, not the Earth, is at the center of the universe. This was a radical idea and not exactly popular with everyone. But Copernicus had set the gears in motion. Then there's Galileo Galilei, who built his own telescope and started observing the heavens like nobody before him. He saw moons orbiting Jupiter and phases of Venus. Enter Johannes Kepler, who figured out that planets move in elliptical orbits, not perfect circles. His laws of planetary motion described how planets speed up and slow down in their orbits. And of course, Sir Isaac Newton introduced the law of universal gravitation, explaining that the same force that makes an apple fall from a tree also governs the motion of the planets, unifying the heavens and the earth under one set of physical laws. Now, let's talk about mapping our cosmic neighborhood. William Herschel took on charting the Milky Way, observing and cataloging stars, imagining it as a disc-shaped collection of stars with the sun near the center. Then there's Henrietta Swan Leavitt, who studied Cepheid variables, stars that pulsate in brightness, discovering a relationship between these pulsations and their true brightness. Q. Edwin Hubble. Using Leavitt's work, he observed that the nebulae were actually entire galaxies outside the Milky Way. This was huge. The universe suddenly became a whole lot bigger. Hubble noticed that these galaxies were moving away from us, leading to the realization that the universe is expanding. So, if the universe is expanding, it suggests everything was closer together in the past, which leads us to the Big Bang Theory. The theory proposes that around 13.8 billion years ago, the universe started from an unimaginably hot and dense point and has been expanding ever since. In 1965, Arno Penzias and Robert Wilson found a persistent hiss in their data, stumbling upon the cosmic microwave background radiation, the afterglow of the Big Bang. With all these discoveries, humanity's curiosity only grew stronger. The Hubble Space Telescope, launched in 1990, has given us breathtaking images of the cosmos. The James Webb Space Telescope is designed to look even further back in time, to when the first stars and galaxies were forming. Remember the Voyager missions? Launched in 1977, Voyager 1 and Voyager 2 have entered interstellar space, making them the farthest human-made objects from Earth. And let's not forget the golden records they're carrying, time capsules filled with sounds and images from Earth. On the exoplanet front, missions like Kepler and TESS have discovered thousands of planets orbiting other stars, with some in the habitable zone. Alright, buckle up because things are about to get mysterious. Scientists noticed that galaxies were spinning in a way that didn't make sense. Enter dark matter, providing the extra gravitational pull needed to hold them together. Observations of distant supernovae showed the universe's expansion is accelerating, with dark energy causing space itself to expand faster over time. So, how far does the universe go? The observable universe is about 93 billion light-years in diameter. We can't see beyond the observable universe because the light from those regions hasn't had time to reach us yet. The cosmic microwave background radiation marks the edge of what we can observe. Now, let's step into the realm of the speculative. Some scientists propose that our universe might be just one bubble in a vast cosmic foam, a multiverse. String theory suggests the existence of multiple dimensions beyond the three spatial ones we experience. There's also the concept of parallel universes, where every decision creates a branch in reality. All this talk about the vastness of the universe might make us feel tiny, but it highlights something incredible about us. We're curious explorers by nature. We're on the cusp of becoming an interplanetary species, with companies like SpaceX working on sending humans to Mars. We're also exploring concepts like warp drives and wormholes. We're part of a universe that's 13.8 billion years old, yet here we are, capable of contemplating the cosmos. But the story doesn't end here. Every day, new discoveries are made, and our understanding deepens. The echoes of eternity are all around us, and the adventure is just beginning.